Bona tarda, buenas tardes i welcome. Acabem de veure l'obra de vídeo Breathing Architecture de l'artista italià Filippo Nassetti, creada el 2024, que experimenta de manera col·laborativa amb models, simulacions numèriques i tècniques de visualització impulsades per High Performance Computing, centrant-se específicament en el sistema respiratori. En seleccionar i estructurar la informació, la bellesa es fa funcional per permetre interpretar, recordar i connectar. Compartir és el tema de l'edició d'enguany del programa obert, un concepte relacionat amb la creativitat compartida, que remet a processos relacionals en tots els sentits. La integració de diferents camps de coneixement permet abordar problemes complexos des de l'interdisciplinari amb una visió holística de tot procés creatiu. La 13a edició del programa obert, coorganitzada per la Fundació RCR amb el Col·legi d'Arquitectes de Catalunya, té en aquesta conferència el suport especial de la Comissió Europea i és beneficiària del programa S+T+ARTS Air. S+T+ARTS Air és un projecte que aprofita el poder de l'art, la ciència i la tecnologia per abordar els reptes urgents als quals s'enfronta la nostra societat. La Comissió Europea reconeix el paper vital de les indústries culturals i creatives per millorar la competitivitat d'Europa i impulsar l'innovació. Integrant art, ciència i tecnologia, podem desbloquejar el potencial transformador del sector cultural, estimulant el pensament crític i oferint noves perspectives sobre el futur de la nostra societat davant els avenços tecnològics i els impactes ambientals. En aquest marc, presentem dos projectes de 10 artistes residents que estan desenvolupant actualment el programa. Filippo Nassetti, amb el vídeo que hem vist, i Michail Rybakov amb la conferència en diàleg amb l'investigador especialitzat en física computacional i sistemes complexos Hygor Melo, de Sony Computer Science Laboratories de Roma. Sota el títol de El cos i la ciutat, abordaran el concepte d'espai personal i exploraran com les ciutats en què vivim influeixen en la nostra experiència diària de l'espai personal. Michail Rybakov és un artista mediàtic, centrat en la interacció del cos i la tecnologia a la vida quotidiana. Ha estudiat l'art multimèdia de la Universitat Estatal d'Art i Disseny de Karlsruhe i va ser mentor pel difunt professor Bruno Latour durant els seus 2 anys de recerca de postgrau sobre el tema estratègies d'arribada a l'espai. Hygor Melo és un investigador especialitzat en física computacional i sistemes complexos, centrat en la ciència de les ciutats i el comportament humà col·lectiu. Té un doctorat en física de la matèria condensada per la Universitat Federal de Ceará, al Brasil, 2016, i actualment és investigador associat al Sony Computer Science Laboratories de Roma. Hygor aprofita de les eines de la física i de les matemàtiques per desvelar informació sobre la dinàmica urbana i les interaccions humanes. Passo la paraula per explicar una mica més a Carme Pigem.
Hola, bona tarda. Molt breument, perquè crec que tenim ganes de veure la conversa que hi haurà entre en Michail i jo, perquè una mica explicar simplement el context dels STARTS. Els STARTS és aquesta ciència, tecnologia i arts, i és bonic perquè quan ho agrupem, aquests STARTS, aquests començaments, són inicis de coses que poden passar, de coses com desconegudes quan posem a treballar realment gent de disciplines molt diferents. L'any passat va començar, de fet, va ser a finals del 22 que ens vam agrupar un consorci de 8 membres europeus, en els quals ens vam presentar en aquest programa dels STARS, aquestes residències artístiques europees, i que es va guanyar aquesta residència sota el nom d'AIRA, aquest Air. I sobretot el que s'intentava fer des d'aquesta crida i des d'aquesta residència, dèiem fer visible allò invisible. Realment tots nosaltres ens movem dintre de l'aire, l'aire és el nostre mitjà comú i no ens interessava tant, perquè era com objecte d'un altre tipus d'estudi, la qualitat o la puresa de l'aire, com quan era un element comú de transmissió de coses. I per tant, hi va haver una crida buscant quins artistes podien ocupar aquestes residències. Es van presentar 180, crec, artistes a la crida, dels quals se'n van seleccionar una primera vintena per quedar-ne en 10. Llavors, avui hem vist en el vídeo un d'ells, en Filippo Nassetti, que com va explicar l'Andrea, està treballant en com podem veure l'estructura dels pulmons i com realment quan veus aquesta estructura penses que són estructures que poden ser molt similars al que pugui estar passant a l'univers i en altres contextes. És veure realment com quan descontextualitzem les coses i veiem només, ens fixem en l'estructura de les coses, aquestes poden ser un llenguatge molt universal. I ara veurem el treball d'en Michail, que ell parla molt de precisament quin és l'aire que ens envolta, diem com a persones, i quina és la relació que tenim entre nosaltres a través d'aquest aire comú. És interessant veure com l'art, d'alguna manera, cada vegada més veiem que pot agafar noves maneres d'expressar-se i que són unes maneres que van molt lligades a tot el tema computacional i podríem parlar, no sé si d'intel·ligència artificial, en aquest cas no estem parlant d'això, però que sí estem veient és com la ciència i la tecnologia es posen al servei de l'art o l'art es posa al servei d'aquestes eines i com tots ells poden avançar en unes noves maneres d'expressar coses. I això ho trobem interessant. En aquest consorci, finalment, per dir, aquests 8 membres són la Fundació Èpica de la Fura dels Baus, el Media Solution Center d'Alemanya, després també hi ha Pina, que treballa molt amb temes acústics, que són un grup eslovens, després hi ha Inforart, que és un grup holandès que treballa sobretot en com l'art ens pot portar a la innovació, i després hi ha com 3 punts computacionals importants, que un és el HLRS de Stuttgart, després l'altre és el BSC, que és el Barcelona Supercomputing Center, i finalment hi ha el que avui tenim aquí present, que és el centre d'investigació de la divisió europea de Sony a Europa i que està a Roma. Quan vulgueu. Gràcies.
So, this. Nice. Can you hear me? Yeah. It works. Amazing. Great. Hi, I'm Michail Rybakov, and I'm the artist. This is Igor, he is a scientist, and we work together on the project Body in the City and Kinesphere in frames per second, which is the subtitle I came up with today. And we deal with the personal space in the city. You are all familiar with the personal space. It's what surrounds you. It is invisible, but it still exists, and which is an important topic because the research topic of the STARS program was making the invisible visible in the cities. So this is how we do it. And just so that we don't just talk around about this, we're going to do an exercise. And for that, I need you to stand up and come forward. Or find somewhere a place to walk around. So just fill up the space. We're going to use it all. No shyness. Just take up the space of this whole building and walk around, feel your body present in this building. Right. So it feels a little bit different when you don't have to sit for the presentation. Now, wherever you are, find a partner, find a pair, somebody right next to you. So break up into pairs. So so you have somebody to work with, right? Everyone has has a partner for them. You can, yeah. Yes. And now try to find your personal space. You can do it by like one partner remains steady and the other is slowly approaching them from a bit afar. And when the other person says like, okay, this is enough, this is my personal space, you just give the sign and then do the same with the roles reversed, okay? Just try it out. Did you find your personal space? Yeah? Did you talk a little bit about it with yourself? So was it a similar space, similar distance, or a different distance? Was it different? A little bit, okay. This is a great exercise because we actually feel like this is the border, this is my space, and you should stop there. Because in an everyday situation, we kind of accept that somebody is coming through our personal space, is infringing upon our personal space. And we can continue walking around this space, just continue, don't stand in one space. But now, as you walk, try to actively protect your personal space. So if somebody is coming too close, change course, step aside, try to maintain this. Does it work? And now, as you walked a little bit, you can change course and try to slowly walk backwards. Try not to step on somebody's feet or fall. That would be unfortunate. But try to feel your personal space as you walk backwards. You suddenly are very aware of what's behind you. Anyway, thanks a lot. You can come back to your seats. Great work. And our question was, of course, well, we feel this personal space, but how can we visualize that? How can we quantify it? How can we work with it from the perspective of a computer, from the perspective of science? And one approach as a proxy to personal space was the kinesphere. The kinesphere is a concept from choreography, from Laban choreography, and it signifies a sphere of potential movement. So you can, how far you can reach, this is your kinesphere. And this we use as a proxy for the personal space. And here you can see a painting of two people, and so here we wrote a program to recognize the limbs, the arms, and create a kinesphere visualization around them. So here, around each shoulder, you see a circle, and around the other shoulder too. So you can see those people probably know each other. They're sitting quite close together. Their kinespheres overlap. Same here. And let me try it live if it works. Oh, it does work. So if I don't fall down from the stage, you might see my kinespheres live, and those are same size circles no matter how I move my arms. Well, and then so this was a Python application that we used for that. And it is using machine learning algorithms and a model trained on human bodies to recognize arms, recognize human bodies, and paint the circles around them. And here I asked the students from Karlsruhe University with whom I work to just do the same exercise that you did before, and then I drew the kinespheres around them. But the question is then, well, we have the kinespheres, but the quality of life is actually probably more influenced by the overlap of kinespheres. So when somebody is moving into your kinesphere, right, as you can see here in this video, then someone is in your personal space. So I used a different script, different approach to only show the overlap of the kinesphere, so kinesphere infringement. Same applied here for the same game. So people try to enter each other's personal space, and then you can see the kinesphere. And on the left, there are some tourists walking through the building, and you can see they probably know each other because they are up into each other's personal space. So we came up with the concept of kinesphere infringement per second. So how often, if you are standing in a space, how often would somebody run into your kinesphere? And because it's a very rich topic, it's a complicated topic, we have to work with different scales. So we have been working on the scale of human body, as you have seen before, with just visualization of a kinesphere. We have then worked with this kind of street-like approach, and the next one would also be a street-like approach, actually, would be this simulation. I'm not sure I have. I'm going to risk it. I'm going to refresh. Oh, it works. So this is a simulation of people meeting in the middle. So there are a few obstacles that we can add, and we can add some more people. And then we can observe what would happen if those two crowds would converge in the middle and try to go to the other side. And each time they converge, or each time the kinesphere is infringed, a little dot, or as Carme said, a bit of dust is being left on the canvas. So it is painting by human bodies. And of course, we can add more obstacles or even try to recreate some kind of geometry. in order to simulate the behavior of bodies, human bodies, in a particular space. So this was the street level approach, street level scale, and then we went to a city scale. So we used data that was made available by Sony CSL, data about density of GPS coordinates in the city, so how often do people use GPS on their mobiles. And this was the first representation, so this is Milan, the center of Milan, and you can see where, like, the green things are the sidewalks where you can actually walk, and the other things are streets and houses. So you can see there's a bit of a different density. And of course, then I tried to experiment with different approaches. For example, removing the streets as far as possible, because you cannot step your foot on the street, because that's where cars live. And if a car lives there, then you, as a human body, should not enter the space. It's prohibited. Then, of course, a different kind of visualization would be to only leave sidewalks and make it an extreme difference. And I quite like this chaotic representation of sidewalks. This has quite a futuristic city feeling to me. Another playful thing that we did was this kind of map that reacts to sound. So as I use my human voice, my voice, it lifts up different aspects of the city and of the sidewalks. It was fun, but actually it is probably more appropriate to an exploration, for an exploration of, sounds in the city. And finally, what we have currently came up with on a city scale is this representation of 24 hours breathe of the city. So the city, if we look at the city as a living organism, this is how it would look like. So the higher the sidewalks, the more dense they are. This is again Milan. And so this is, of course, work in progress. We are currently a bit past halfway of the residency, and so the next step will be to bring it all together, to create a narrative around that, and to present it in October on a festival in Barcelona. This is from me, and I give the word to my scientific colleague, Hygor. Please enjoy.
Okay. Can I move this a bit, like this? Okay. So, hello everyone, good afternoon. So, thanks Michail, thank you all, thank you for having me here today. So it's a pleasure to be in this place. Oh, it's too loud. Yes, maybe it's better. Okay, so I'm here, I think, to share a bit of the scientific side of this project, which it's not easy because it can be a bit boring. So I will try to be less boring as possible. So my background is in physics, and it's worse than that. Actually, I'm a theoretical physicist, so zero experience on doing experiments. So the opposite of what Michail just did. And it's, as you can guess, even by the quality of my slides, the visual quality, I'm very little experienced with art.
They're great.
They're great, thanks. And it was the experience on working on stars make me thinking on this interaction between science and art. And I want to share a bit on my personal perspective on how I change some of my ideas to also be able to collaborate. So I want to give an example of how we can connect science and art, and I will use this. I guess it's a kind of a new concept of generative art. I guess most of you knows, but it's very hard to define what it is. And so generically speaking, you produce art by having an algorithm, an automation. And typically it's using a computer, but not necessarily. So you can do this even using mechanic or chemistry. But typically what we do is we use an algorithm to generate a piece of art. And as I was getting involved with stars, I was learning more and more about this. And one of the things that I found fascinating that I discovered is I don't know Japanese, but I think this is, I don't know if someone here reads Japanese, but there is this hashtag, and in Japanese it's tsubuyaki, processing. Processing is a language, coding language for artists. And if you put this on Twitter or X, whatever it's called today, you're gonna see this amazing works. And there is one thing that is very important is you need to, okay, you can post your art there, but the code that you use to generate that video must fit on one Twitter. I mean, the old Twitter. I think it was, what, 200 characters or something like this. So when you look to it, it's incredible because it's impossible. By looking to the code, it's impossible to predict what will come out from this code. Because you have this strong constraint that you need to make your code so small that it becomes very hard to read. And I started to learn a bit about this process of coding and generating these images and videos. And I realized that this is basically what I do as a scientist. So when I was trying to do this and I was reading about it, I see that usually the artist had something in mind. They have an image on a video that they want to create. And then he needs to mentally think on how to code, how to create a model to explain to the computer to generate that image and video. And us as a scientist, this is basically what we do. But what we do is we don't create this image from our mind. We see this in nature, no? I see a pattern, and then I need to come out with a code, a model, that when I introduce to the computer reproduce something that is similar to what I see in nature. And by doing this, I'm explaining a natural phenomena. So on that sense, I mean, I'm being a bit provocative. I started to realize that I am also an artist. So I think if it is very bad draw that I did of a Venn diagram, so you have art, then you have generative art, and science, it must be inside it. We have strong constraints. No, I cannot generate anything because I need to generate something that it's similar to what I see in nature. No? But when I started to think like this, I think my process to understand and collaborate and think of what will be the outcome of this project started to be a bit clearer for me. So I want to give a real example of how we do this. I mean, these amazing guys who did this work a couple of decades ago. So this is like a classical model of human mobility. It's called radiation model. So basically, what you have is this picture. This is US, and these are the vectors represent the commuting, the flow of people that goes to work on different countings on US. And the colors and the size represent this flow. So this comes from, from nature, from society. And we as a scientist, we need to come out with a model that will reproduce this image again. And what they did was, okay, they thought on some assumptions. Or they think, I will not enter into the details, but they simplify the problem. They think every person needs to search for a job. Every city must have a number of jobs that is proportional to the population. People search for a job that is near their house. And then they play with these rules. And with this, you can put on a computer. And if you are very, very lucky, usually you are not, you can get like a mathematical formulation with this. But most of the times, this is impossible. You just put this on a computer, simulate, and generate an image again. So that's why I think under some aspects, this is a kind of art too. And then you compare your image with what it comes from nature, no? If you see, it's not perfect there, no? But it's better than the previous representation, the previous model. So you keep one step ahead on explaining natural phenomena. But the mindset, the way it works, is not so different from the guys who are doing generative art. You know? So this was some examples on how I think we started to adapt ourselves for this project. And now I want to move a bit for more concrete stuff. Okay, I need to see the time. This is the group who works on Sony CSL ROM. So we are a small lab. It's quite new, the lab. There are 4 Sony CSLs in the world. There's 2 in Japan, and 2 in Europe, 1 in Paris, and now there's 1 in Rome. So the director is Vittorio Loreto, this guy behind me. And we have 3 research lines. And the one that I participate is the sustainable city, so we work with science of cities. Me and Matteo Bruno, this guy here, okay. So I am a physicist, and Matteo he's a mathematician. And yeah, we do different stuff, but what is the central topic that connects these research lines is the idea of complex systems. This is what we do. So we research different systems, but in the end, we can use the same theoretical framework that comes from this field. So maybe some of you already have heard something about what is a complex system. It's a bit hard to define because there is no clear definition of what is a complex system, actually. I like the definition that says that there are some people who say that I don't know how to define, but I know when I see one. So it's more or less my approach. But every complex system has some features that are always there. So one of the things that is very much connected with what Michail was doing is this entanglement between different scales. So when you have a system that is complex, you cannot take a picture on a single scale and try to understand that system by this picture. Because things that are happening on a very small scale, you have cascades that will affect the overall behavior. So this happens on time and also on length. And also in the number of agents. So if your system is a city or a society, the number of elements also affects the overall behavior. So understand a single agent and understand the whole dynamics of that agent, it doesn't mean that you're gonna understand the collective. So when you go to this large scale, the patterns that you see are not trivially derived from the fact that you understand a single agent. And the concept that is, the name that is behind of this is emergent. So we call this emergent patterns or emergent behavior. When I look to the cities, I can say that the city is a complex system. Of course, I was not the first one to say this. I guess everyone here probably have read Jane Jacobs. And for me, it was fast as a physicist when I started to read the book and I saw the last chapter. She talks about physics, and for me, it was like amazing to read it. Someone starting by discussing the life in a city, and then she was like discussing about statistical physics, which is my field. And she says that the city lies in this transition of scales. The city is not composed by one single particle or agent, but it's also not infinite like a gas, because these two regimes the physics have solved. When you look to this very small scale, couple of particles, you have mechanics. When you have infinite particles, you have thermodynamics. She says this in the book. But the biology and the sociology, it's hard to come out with a theory, and she calls this organized complexity. And what we do in the lab, I mean, to be concrete, I think I'm okay with time. What we do in the lab, so yeah, we do research on cities, and I will just show a couple of examples that in the end will be connected with the idea of our research together with Michail. So we have this open platform. I invite you to later to check this. We call it What If Platform. So it is both a photography of the city, of a city, but there's also what is called digital twin. So you can use this to forecast and predict and play with different scenarios. And there you'll find two tools. One is the 50-minute city, and the other one is the city cron. I can explain a bit better both of them. The 50-minute city, I guess all you know the concept now. It is this utopic idea of you have a city where you must reach the nearest services, essential services, in less than 50 minutes by walking or cycling. And this is like a strong topic of research in our lab. So if you open this platform, we cover most of the world. You can click on the cities and you can have an overall description. That here's this overall, this large scale. So you see the city, this is Rome. And in red are places with bad accessibility. And in blue are places with good accessibility. So you have good proximity for essential services. We can study inequality. So what is the fraction of people who live on each one of these cities with good accessibility? And we can go beyond, like we developed an algorithm to redistribute, where it take the spatial distribution of every point of interest in a city or service, and we can reallocate this theoretically. And to do this in practice, again, we work with theory, so put this in practice is another level of complexity. But we can show that we can reduce inequalities just by rearranging the position of these services. And here's just one example how you can change a city by changing the position of a couple of services. So it's a bit hard to see by the colors, but the overall idea is we show that you can improve. People who live in the city center will have to pay a price by reducing a bit their accessibility. So a guy who lives in the city center will have to walk 1 minute, 2 minutes more in average. But we show that by paying this price, you can increase the accessibility of people who live in the periphery of 5 to 10 minutes. So you have this balance. If you don't want to create new services, you can just rearrange it then. And all this in theory. and then you can improve accessibility. In the case of the other two, the Citychron, here we actually start accessibility, but by public transportation. And it's also a tool for creating new scenarios. You can introduce a new metro line on your city and recalculate the accessibility, the overall accessibility of your city. And we are combining all this in a way to measure the impact of cars on cities. So we can calculate accessibility to reach a certain number of opportunities or services by car and compare with public transportation. And then we can create, and this is an ongoing project, we can create what we call a car dependence index. So it's a number that tells you, okay, here I really need to use a car because I will reach much more opportunities than someone who is using the public transportation. So in blue are regions that it's better to use public transportation, and in red are regions that you basically have to use a car. We can do this for different cities, as you can see. And one of the things that we are doing now, and that's why this is extremely connected with the data set that Michail is using, is we are using mobility data, very accurate GPS traces of people moving in Italy, and we can recreate the path of these people and where they were on specific times of the day. And here we have how people were like visiting a park in Florence and also another park in Rome. And we want to understand how people use these green spaces in cities. And using this same data set, we could also calculate how they are moving the sidewalks. And this is what we want to explore with some of the works that Michail just presented. So this is a picture of the map of Milan. And if you go back to my presentation in the beginning when I said, look, I have the map and I have to create the model. This is the scientific question for us. When I look to this map, I see the colors, I see how people are using the sidewalks. Can I create a model that explains this pattern? We don't have this yet, but in case we do, it means that we are getting one step more in the direction to understand human behavior in cities. Of course, under some assumptions, as every work in science, but this is the type of questions that we always have in mind. So if I have this picture of the city or this video, what is the model that I need to write to reproduce this on my computer? And by doing this, I'm getting knowledge. And then it comes the scale, because in some of the experiments, we move to look to one single person. So can we look to these videos and understand how do people move around depending on the space that they have available? If I can deduce this, I can go to the computer and try to simulate what will happen in a large scale. The last thing is, this is like a technological application, and this is something that we are working. I mean, it's not ready to be used, but in this application, you can go to Milan, and you can put two addresses, and it will search the optimal path, the minimum path. So if you want to walk the minimal distance, and we'll plot in the colors, you see the density of people that you're gonna face. So then you might decide, look, today I don't want to see not a single face on the street, so maybe I will not leave my home. And we can also redesign this routing machines that is called like, how do you find paths to search not the minimum distance, but like the maximal density of people if you want to see a lot of people, or the minimal density of people if you don't want to see no one on that specific day. So we can play a bit with that, but yeah, this is we work on it, but it's quite there. And with this, I finish my presentation, and yeah, I hope you guys have some questions. Thanks.
I take this one? Sí. Okay. Do we start to ask people if they want to make some questions, and you make like, yes?
Yes.
We do this?
Please,
Okay.
someone.
So is there anybody who would like to share something about what we have learned now? Is somebody?
I know that you guys are a bit stressed today with the
Yeah.
Thank you guys for the presentation. It's been so interesting. And since you were talking about this last app that you are developing, it came to my mind about the possibility of creating like your own city in terms of adding information as you are looking for a destination. Maybe you can add some inputs to that app that will make your own experience regarding to that kinetic personal space. So I don't know if it's a question or just opening just a topic of possibilities that can open this data.
Yeah, no, maybe I can start. And yeah, this is perfect possible, and this is actually a direction of several research groups. There is an ongoing discussion. What is the impact of people using Google Maps when they are like driving cars? Because maybe the Google Maps is also creating more traffic because it guides you on everyone on the same street, and there are other impacts that maybe in Europe it's not relevant, but for instance in Brazil, sometimes it's dangerous to use Waze or Google Maps because the application just gives you the shortest distance, and the shortest distance might be a bit dangerous, you know. So you need. It seems that today there's this urge of make it a bit more personal, and technically I think it's possible, you know, and we are like trying to move on this direction, looking to ways to also use like the amount of trees you can see on the path. So some people will, I would like to walk, but not in the shortest distance. I want to go through the distance where I see most of trees, you know? So this is perfect possible. I don't know in a massive way, like what Google does, but in small experiments like what we are doing, it is possible. And this is something that we wish to do.
I can just only add to that of course, as we live in a city, we add our own personal history. Here my ex-girlfriend used to live. Here I met a crazy person who was not my ex-girlfriend. And overall, of course, the lived experience in the city is a very personal thing, but I don't know how to add it to a map. Maybe there's a technical solution for that.
Is there a question? Yes, well.
Bueno, digamos que me gustaría, digamos, hay como las dos vertientes, ¿no? Ver cómo desde cuando se estudia la quinesfera y esto viene como del artista y luego se le ven aplicaciones como técnicas, ¿no? Decir, bueno, pues yo voy a usar el camino más, digamos, como más lleno, más vivido o el más vacío, ¿no? Luego para mí también está como la otra vertiente, ¿no? Realmente, es decir, con todos estos datos, ¿no? ¿Cómo puedo yo dar una expresión artística a un determinado tema, ¿no? Entonces, ¿no? Es como, para mí funciona también como en las dos direcciones, ¿no? Como el arte abre caminos en la ciencia y como la ciencia, ¿no? aporta nuevas expresiones al arte, ¿no? Quizás si podríais hablar un poco de esto, ¿no?
Sí. I mean,
Did you understand?
yes.
Oh, good.
What did you? No. Yeah, I can try to translate.
No, you
I,
can, you
I
can,
don't
you,
speak Spanish, but
you can
I
try
speak
to.
Portuguese, so it's similar. I mean, if I understood well, you want to understand what is the influence, what is the dialogue between these two, no? I mean, if I understood well, you said like, what are the doors that the artist can open for us, and what are the doors that the science can open for the artist? On help on our expression, yes. I can give you the most naive answer, and then I leave to Michail to reply. One thing that the art can help is like in communication, like communicate art, science. It's very hard, and art can help on create awareness. No, like people will be seeing more what we do. I think this is the boring part. I mean, it's a bit the first reply that every scientist will say. Because it doesn't mess it up with our work, no? We just do what we do and then leave to the artist to come out with a way to express this. And I don't think this is the right approach, but I think this happens a bit. And would be the easiest one. I think what is hard is to have this inspiration, no? Is what it comes from art, and then you start to think. I can give the example of Jane Jacobs. Like, I mean, it was not art, but it was literature. She was not an urbanist, and she was not an architect. She was a journalist, and she wrote about science, and she inspired several architects, urbanists, and scientists. And I can consider, I mean, it's a book, it's also a piece of art, and she inspired people to look to the city under a different perspective. I don't know, what do you think?
You make sense. When you talk, you make sense. And this is a great quality of scientists. They actually make sense. But for our working together, I think, or at least for me, art has to have some tension, and there is a lot of tension between the scientific worldview and the artistic ones, and we noticed how we speak different languages.
Yes.
We speak the same, we say the same words, but we mean different things.
Yeah.
And through this tension, something can be found, something new. And at least for me, art is more about something that is invisible in a sense that it's there, but you cannot look directly at it. If you look directly at it, it disappears. So you have to look like a bit to the side, and then you can see it. And this was also my approach to working on this project, was to say, well, I try this, I try that, I try different technological solutions, and something in between, in the middle, will come up that is more than the sum of all the things that I did, of all the experiments. And so this was the technological, or the thing that the technology adds to artistic exploration, from my point of view. Yeah.
I can finish with one example that just came to my mind, is this simulation that Michail showed, like of people walking on the streets, the dust, that as you said, after you said the dust, it was also inspired by your vision. I really, in the beginning, I didn't care much what Michail was doing, but then Carmen said, "This is the dust," and then I was, yes. And for me as a physicist, I think as a fluid, no? I think that the dust that we see, it has information. And when I looked at it, and I went to think, how can I retrieve some information of what is happening behind just by looking to these small white dots? And I haven't thought about it before seeing the simulation. So this first came the art, and then after it came the question. So perhaps this can be a good example of this interaction.
Okay.
Hi. Thank you for your interesting lecture. I want to ask you from both of you point of view. I think we architects and you both like scientists and artists, we have something in common that I want to ask if it happens between both of you, is that we are very curious and that we have some kind of intuition for things sometimes. Because I guess you have to choose what you need to research, and you have to choose what you want to work on when you're performing your artwork or whatever you're researching. So there is some kind of intuition about what are you going to try to do, no? You pick one thing and you don't pick another one. Do you think in your conversations about what to do, there is something about those intuitions from different points of view that comes up, or?
Yeah, I think it's absolutely true for me that I have some intuition that, okay, if I try this, something interesting will come out of it. Often it is limited by technological solutions that are available to me, but other times I can just try again from different perspectives, and something interesting will come out. But the hard thing about that is to communicate this intuition. Because while I have this intuition, and from my experience, I tend to believe my intuition, it's hard to communicate, like, guys, listen to me, something will come up, just wait, just let us try another experiment, let's do again, because I feel that scientists don't work on intuition.
Yeah, this is a bit of a polemic topic in science, no? Because in theory we are pragmatic, no? I mean, we have a pragmatic mindset, so it should follow some specific specific outline on my work, which is a lie, because we use a lot of our intuition, and better is the scientist, more he uses his intuition. And all the time we do this. And it's hard to explain because it's something that comes with experience, no? And I can give an example, like if Michail tell me, okay, I'm doing this simulation, and the way I'm implementing the interaction between these particles, it's like this. And during my life, I have done so many of these systems that I kind of know what probably will come out too, you know. But Michail is right, like we both have intuitions, but perhaps the tension is how to communicate these intuitions between each other, no? But yeah, the collaborations, it's tense. Don't think that we are fighting, no? But this tension is good too, you know. The outcome, it's incredible. It's amazing work. So yeah, I can give you exactly example of how the intuition plays out on this work, but it is there on both sides a lot, I think. Thanks.
Okay, another question.
Hola, mi nombre es Sofía y yo soy de Costa Rica. Quería preguntarles como que si existe o se pueden utilizar estas herramientas. Do you understand me? Like,
I think yes, but
Okay.
if you go slow, it's better.
ok. Si se pueden utilizar este tipo de herramientas en regiones latinoamericanas o centroamericanas y si no, ¿cómo se pueden generar estos datos en estas regiones donde el acceso, donde se necesita esta información, pero pero existe un rezago en el acceso hacia esta información?
Okay. So she's asking if we can use these tools in Latin America. And what was the second question, sorry? The second, it was?
Sí, sí, digamos, si no se pueden, si no funciona en Latinoamérica, ¿cómo se puede generar esta información?
Okay, I think I got. I mean, if also there is some lack of data, and how can you generate this information in case it's not easy? Do you want to?
Yeah, actually, a month ago, I was giving a presentation about my work, and like, most of what you saw, I showed there too, at Tecnológico de Monterrey, which is a university in Mexico. Because they were also very interested in this kind of art-science collaboration and how it could work. But of course, with the lack of data, there's a difficulty. Still, I think, yeah, there could be a solution.
Yeah, I mean, this is an important topic for me, no? Because I came from Brazil. I mean, I live in Italy, but first, data. The data is not as good as for Europe. So if you look to our platform measuring accessibility, we cover most of the world. But the data comes from an open source, an open website where people put by themselves where it is located every service. It's not from Google. So people go there and put like, here there is a restaurant. And of course, people in Europe and in North America, they do this more often. So the coverage is not as good for it's okay in Latin America, I would say. In Africa, it's more difficult to work. So I think it's possible to work with what we have. Regarding on apply this, yeah, I mean, for me, so I came from a city that is, it is even today, but it was worse when I was a kid, one of the most violent cities in the world. I mean, among the 10 most dangerous cities. And when I look to our research, the first thing I think is, I mean, on safety. How can I trace? Every time that you do this path, if you see a lot of people, your chance to get robbed, it's higher too. Actually, it is a theory of sociology about this. So there's people who do research. In Europe, this is a bit irrelevant, you know, like, but yeah, but this is an important topic if you go to Brazil or, I don't know, Costa Rica, no? So in Latin America, like, the first question would be like, can I use this to improve my safety? Yes, it's possible. And I want to do this as soon as I can.
Okay, so another question. ¿Alguna pregunta más que queréis hacer? Sí.
Hello. I just want to say that I think that this is amazing for the work that we are doing now, because we are working with Sagrada Familia and there's a lot of problems with people that live there and the connection with other people that comes to that place. So I'd imagine that this could be like a prototype of a project and could be like the entrance of Sagrada Familia, and then the people who lives there, it's a color of a point, and I don't know, the ones who pay the ticket to entrance, it's other color, and you can anticipate a problem or anticipate how a project could work or not, because there are projects with a huge urban impact. So I don't know, I think that it would be a good tool for that kind of projects.
Thank you. It's online now. I can share the link somehow, so you can try it out.
It's online, it's working, we can...
Yes, this URL on the top is actually where you find it.
Show the map, maybe.
Sorry?
The map. The map with the...
So you can choose how many dots.
The map with the...
Yeah,
You can choose how many dots and how many collisions.
About this, if can I click on the map?
Sure.
What is the map? Sorry.
Which one?
Yes. So maybe the one moving.
The moving, this one.
Yes. I don't know. So this is the Duomo in Milano. It's like Sagrada Familia. And when we look to the data, we always have a spike there, which is a problem for us to visualize, actually. So there are so many tourists there that it's always red, you see. It's always red. So we get this signal. Unfortunately, we don't have data for Spain, but it's possible to acquire this type of mobility data. So we could know how many people are visiting Sagrada Familia and how do they are moving around, you know, because this is the same for me. It's the same problem. I mean, Barcelona is probably a large scale, but yeah.
Mm-hmm. Is this a kind of twin model?
Kind of?
Is this a kind of twin model of Milano, or is it just only a scale project of the city? It's not a twin model.
I don't know what precisely do you mean by twin model? Like if we have more features than mobility or not?
Yeah, how the simulations are only done on the ground floor,
Yes.
on the ground of the city. It's not. It's. Do you have also 3D versions of?
I mean, there is the 3D imprint of the buildings, no? Like we know the shape of the buildings, no?
Mm-hmm.
And from this, we know the GPS point of people. And then we can project and see whether the person it is inside a sidewalk or not. And then we can change the size of the sidewalk in a 3D, but looking like a building, but it's just a way to show how many people were in that sidewalk on that specific moment.
Mm-hmm. Do you have any question? ¿Queréis hacer alguna pregunta todavía del tema? Uh-huh. They don't dare. No, because we are working, and one exercise in the workshop is about the, yeah?
Slow.
Slow. Oh, I'm sorry, I cannot do this here, but we can. The time.
It's too fast, yes.
I can change it in code, but it will take a minute.
You're going to change life?
I don't know.
Yeah, because the project they are doing is around, is the public space around Sagrada Familia. So, so this seems to be a tool which could be very interesting for studying, because they are working on what happens with the daily life of the people who live in Barcelona and what happens with all these tourists. So, so there would be like the personal space of the people who live there and how they can have a place which is livable.
I see.
And the tourist fluxes, no?
Yes.
Yeah.
Yes.
So this could be like something that could be interesting to work in a further stage of this project. You see, because they are thinking how green space has to be, which services you have to give, how you have to handle with all these fluxes. So it's really a hot spot now on what they are working in this moment in the workshop. Yeah, because there is even a real problem on how citizens from Barcelona perceive it, and how they think this is a place you can't enjoy anymore, and how tourist fluxes work. So there is really a friction between different personal spaces. Even.
Yes.
I mean, this comes very much to the point of what's happening there, and how you can interact with both levels of experience of the space.
What I can say for this is that we don't, from the data we have, we can't differentiate if the GPS, if the trace comes from a tourist or a resident. But the telecom companies know, and is it possible to acquire this data? Or because they know by the SIM card. If you have a SIM card, for instance, right now, they know that I am a tourist in Olot, because my SIM card is from Italy. So this data exists. So if you have access to this data, and it's possible to have, you can see how people are moving around, and if they are tourists or not. And how do they fight for space, I guess.
Yeah, you could give them like different colors of who's walking and being a citizen of the city, and who's well, a bus which is opening, and I don't know, 50 people going out, and yes, what happens there? It's like with the points, you were doing something.
Yes.
There was an application a direct application of your investigation, really, you know? Because tourism, for example, there's safety is one thing, and tourism is another big item today.
It's a big topic here.
Yeah, it's a big topic. Yeah. All right.
Sorry? The what? The right what?
The collisions.
The collisions.
They want to finish with the points. What's happening with the dust? Well, in Sagrada Familia we would have very much dust.
Yes.
The one the people are walking.
What?
Right, a second.
Yeah, this one, yes.
Yes. So thank you. This is
Thanks a lot.
really interesting. Great.